In this video, we're going to be talking about vertical stretch and compression. We are going to be calling this A. So if you look at the top line here, f of x is equal to A sine x. So A is in front of the sine x, and it does a couple of things to our graph. So our first example is g of x is equal to 5 sine x. So if you notice here, there are two graphs. The blue graph is our original sine x. So this is a graph that you learned about earlier. This is a graph that starts at 0, has its peak at 1, heads back to 0, has its trough at -1, and then heads back to 0. Now, if we look at the red graph is our 5 sine of x. The 5 sine of x is the exact same shape, except now instead of having a peak at 1, it has a peak at 5. So all of these values that we have been multiplied by 5. After it hits its peak at 5, it heads back to 0, so it's resting. And then it heads down to its trough at -5, and then back to 0. You're probably wondering what this 5, or what this A of 5 changes. So the first thing that it changes is that everything is multiplied by 5. And when I say everything, I mean all of my y values. Now, this obviously means that my amplitude is now 5. My period is still 360, so nothing changes that way. And my equation of the axes, so equation of axes, is still at y equals 0. So nothing changed that way either. My resting place, or my middle, is still the exact same. Our next example says, how does the value 1/4 in the function g of x equals -1/4 sine x change our sine x? So again, we have our original graph in blue. So I've kind of expanded this graph so it looks like it's taller, but really if you look, it's still just hitting 1, back to 0, down to -1, and back to 0. Now my new graph, the -1/4 sine x, there's a couple of things that we need to talk about here. The first thing is going to be the negative. So the negative means that instead of starting by going up, we're going to start by going down.
Noah.
The 1/4 means that instead of having an amplitude of 1, we will have an amplitude of 1/4. So we're starting at 0, we're heading down to 1/4, back to 0, up to +1/4, and then back down to 0. So just to recap, the negative in my A value means that we have a reflection in the x-axis. The fact that A was 1/4 means that we have this vertical compression. But really, what it's saying is that our amplitude is now just 1/4 instead of 1. My period is still 360 degrees, and my equation of the axes is still y equals 0. All right, and in our last example, how do the values -2 and -3 in the function g of x equals -2 sine x minus 3 change our original function sine of x? So the first thing that we notice is that we do have this a value here. The next thing that we're going to be talking about is the fact that the -3 is our c value, which we know is a shift up or down. So when I'm taking a look at this again, I drew my original graph in blue, so start at 0, head to 1, back to 0, down to -1, back to 0. Now, the next graph that I have drawn here is the red graph. The red graph is taking into account that we have this -2 for our A. This means, the negative means a reflection, so instead of heading up first, I'll be heading down first. It also means that my amplitude is 2 instead of the original 1. So starting at 0, I'm going to head down to -2, back to 0, up to +2, and back to 0. The final graph that I have drawn here is the purple graph. This is taking into account this C. So this C is a -3. This means that my red graph, or the -2 sine x graph, is being shifted down 3 units. So there's a couple of things that you're going to notice. The first thing is that our equation that used to be at y equals 0 is now at y equals -3. This indicates my new starting point. Now there are a couple ways that you could draw this graph. You could start at your new starting point of -3 and go down 2, back to your middle grounds, up 2, back to your middle grounds. Or you could take each and every point, not just that point, and transform it down 3 units. So this one that was at 0, 0 is down 3 units. This one that was at 90, -2, down 3 units. All of these key points could be brought down 3 units to get to my new graph. And finally, just to tidy things up, we're just going to talk about what's going on with this new graph that I have here. So the first thing is that there is this reflection in the x-axis. The next thing is that we have an amplitude of 2. And we still have a period of 360 degrees. My new equation of the axes, so this has changed because of this C, this shift down. My new equation is y equals -3.